Okay, let us do the problem. Find the Fourier transform of f of x is equal to e raised to minus x square, and hence find the Fourier transform of x into e raised to minus x square. So all of us know that the formula for Fourier transform of a function given by f of x or f cap omega is equal to 1 by root of 2 pi integral minus infinity to infinity f of x e raised to minus I omega x dx. So we know that this is the formula of Fourier transform. Now we will substitute the value, so that is equal to 1 by root of 2 pi integral minus infinity to infinity f of x is e raised to minus x square into e raised to minus I omega x dx. Now it is equal to 1 by root of 2 pi integral minus infinity to infinity. Now adding the powers, e raised to minus of x square plus I omega x dx. So what is now under the integral sign is a function which seems to be very complicated, like e raised to minus of x square plus I omega x, where any direct integration is not possible here. So what we do for such type of functions is consider this term x square plus I omega x. Let us complete the square, that is x square plus I omega x. How do you complete the square? Usually how we complete a square is, we will take half the coefficient of, that is this is of the form a square plus 2ab plus b square. In order to complete the square we need a term b square. So we have to find what b is. So that in order to find the third term, we will take, actually our term is a plus b the whole square is equal to a square plus 2ab plus b square. This is a complete square. So this is a square and this term is 2ab. So this is the b which you have to find out as the third term. So usually this third term is obtained as squaring half the coefficient of the first term, half the coefficient of a in the second term. That is the value of b. So similarly here we get x square plus I omega s, half the coefficient of x is given by I omega by 2 the whole square. It's added and it is subtracted also. I omega by 2 the whole square is subtracted also, so that it becomes x plus I omega by 2 the whole square minus I omega by 2 the whole square, which is again x plus I omega by 2 the whole square minus I square is minus 1 minus 1 minus 1 plus 1 omega square by 4. So this is the term which we get on completing the square of this exponential function, comes as the power of the exponential function. Now this becomes 1 by root of 2 pi integral minus infinity to infinity e raised to minus of, we have completed the square now as x plus I omega by 2 the whole square plus omega square by 4, which is same as x square plus I omega x. We added and subtracted the same term so that we get a complete square plus another term into dx, so that it is equal to 1 by root of 2 pi integral minus infinity to infinity. Now we separate the terms, e raised to minus of x plus I omega by 2 the whole square is one term into second term is e raised to omega minus of omega square by 4 dx. Now how this came again as a simple integral is like this. So as we have the term here, so we have it's is equal to 1 by root of 2 pi. Now see the function under the integral sign is e raised to minus of x plus I omega the whole square into e raised to minus omega square by 4. And we know that the integration is with respect to the variable x, so that this term is a constant, so that we can take it outside the integral sign. So it is e raised to minus of omega square by 4 into integral minus infinity to infinity e raised to minus of x plus I omega by 2 the whole square dx. Now you will be again thinking how we can find out the value of the integral, this integral now. That is how is 1 by root of 2 pi into e raised to minus omega square by 4. And let us put x plus I omega by 2 is equal to some t, so that dx is equal to dt, and limit is also same as x varies from minus infinity to infinity, t also varies from minus infinity to infinity. So there is no change in the limit, so that it becomes 1 by root of 2 pi e raised to minus of omega square by 4. Substituting that value as t, it becomes e raised to minus of t square dx is dt. Now the value of this integral, I don't know whether you know the result, minus infinity to infinity e raised to minus t square dt has the value root pi. If you don't know this result, now onwards you by heart this result, integral minus infinity, this will be used many topics. Integral minus infinity to infinity raised to minus t square dt is equal to root pi. So substituting here, this is equal to 1 by root of 2 pi into e raised to minus omega square by 4 into root of pi. Root pi and root pi cancels. So the answer is 1 by root 2 into e raised to minus of omega square by 4. So this is how we obtain the Fourier transform of e raised to minus x square. So എന്താ ഓർക്കേണ്ടതെന്ന് വെച്ചാൽ e raised to x plus x square plus I omega the whole square എന്ന് വന്നെടുത്ത് നമ്മൾ സ്ക്വയർ കംപ്ലീറ്റ് ചെയ്യാൻ വേണ്ടി ഹാഫ് ദ കോഷ്യൻ്റ് ഓഫ് സെക്കൻഡ് ടേം എടുത്ത് ആഡ് ചെയ്യുകയും സബ്ട്രാക്ട് ചെയ്യുകയും ചെയ്യുക. അതിവിടെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. എന്നിട്ട് അതിനെ ഈ ഫോമിലേക്ക് കൊണ്ടുവരാനാണ് നമ്മളത് ചെയ്തത്. ദാറ്റ് ഈസ് ഇൻറ്റഗ്രൽ മൈനസ് ഇൻഫിനിറ്റി ടു ഇൻഫിനിറ്റി e raised to minus t square dt. ആ ഫോർമുല ഇത് നിങ്ങൾ keep in mind that this value of this integral is root pi. So that your answer is 1 by root 2 into e raised to minus omega square by 4. Now again you are asked to find the Fourier transform of x e raised to minus x square. Now you will be thinking whether you have to again start with the formula of Fourier transform of f of x and do the same procedure. But here we are not doing in that way. We are just applying one property of Fourier transform which you should study, that Fourier transform of f dash x is equal to minus I omega into Fourier transform of f of x. This formula I have given to you in a note which consists of the properties of Fourier transform. So you need to by heart this formula, that is Fourier transform of the derivative of a function f of x is equal to minus I omega into Fourier transform of f of x. So here we have f of x given as e raised to minus x square. Then what is f dash x? F dash x is differentiating this with respect to x, we get e raised to minus x square derivative is e raised to minus x square, minus x square derivative is minus of 2x. That is minus 2x e raised to minus x square is f dash x. From here you get x into e raised to minus x square is equal to f dash x divided by minus 2, isn't it? From here taking it to the left hand side you get x into e raised to minus x square is equal to f dash x by minus 2. Now we write down the Fourier transform of x into e raised to minus x square is same as here we have written here. It is the Fourier transform of f dash x divided by minus 2. Now you can take minus 2 outside, minus 1 by 2 outside because of the linearity property, and Fourier transform of f dash x. And what is Fourier transform of f dash x? By this formula, Fourier transform of f dash x is minus I omega into Fourier transform of f of x. Then what is Fourier transform of f of x? What is f of x here? Minus minus plus. So I omega by 2 into Fourier transform of f of x here is e raised to minus x square, isn't it? It is e raised to minus x square. And that we already obtained as the value 1 by root 2 into e raised to, that we got the value as is equal to I omega by 2 into 1 by root 2 into e raised to minus omega square by 4. So now cancelling the term, you will get I omega by 2 root 2. Not cancelling, simplifying the term or taking all the term together, get I omega by 2 root 2 into e raised to minus omega square by 4 is the Fourier transform of the function x into e raised to minus x square. So whenever you have just asked to find the Fourier transform of a function along with other function, there will be used this property of Fourier transform like this. So you have to go through the steps one by one, and if there is any doubt, you just ask through any media. Okay, thank you.